And you know one thing, the radiation intensity is function of angle theta comma pi. But whereas for isotropic radiator, it is independent of angle because it radiates uniformly in all direction. Or what is another definition of radiation intensity? Radiation intensity means power radiated per unit solid angle. We know the solid angle in isotropic case is simply 4 pi. So power radiated divided by 4 pi. But for practical antenna, we do not know what is solid angle. Okay, it can be anything because say if the practical antenna radiates in this direction, then again here I have drawn it in 2D, but please imagine in 3D, then you'll get some solid angle. Okay, you'll get some solid angle, say in one plane, say in a theta plane, because there are two planes. Okay, in two planes you are having radiation pattern. In another plane, like a vertical plane and horizontal plane, if it is a horizontal plane and again vertical plane also will be there, there also you have to calculate the beam width. Okay, so you'll get two types of angle. You'll get two types of angle. So one is calculated at theta and another one is calculated at pi. Then simply, very simply, again, once if we combine these two, that is in a 3D case. So in 3D case, we are calling it as a solid angle, but we do not know what is that solid angle. But one thing is very clear, the power radiated is same. Okay. See, in the case of practical as well as in the case of isotropic, power radiated is same. So power radiated divided by solid angle, power radiated divided by 4 pi, then PR cancel. So finally you are getting 4 pi divided by solid angle. Okay, the solid angle notation we are writing like this. Okay, in antenna, this is the solid angle notation, 4 pi divided by something like ohm and A. Okay, ohm A. So this is the solid angle, 3D solid angle. Okay, this is the 3D solid angle, and this 4 pi is the 3D solid angle of the sphere isotropic radiator, because for a sphere it is completely 4 pi, but for other shape we do not know what is solid angle. Okay, that can be found out, okay, with help of 2D angle. Okay, this is calculated in 2D plane, because you will have either horizontal, you are having horizontal plane as well as the vertical plane. Then in the horizontal plane you calculate the half power beam width. Okay, in the horizontal plane. Similarly, in the vertical plane you calculate the half power beam width. You know what is half power beam width? Okay, the beam width over which the power is always more than half of the power. So once if you go beyond the beam, then beam width, then you'll get less than the half of the power. That's the idea. So 4 pi divided by half power beam width in the theta plane, theta half power beam width, product with the pi half power beam width, because you are having two planes. So in each plane you measure the half power beam width. Okay, this is the another way to calculate the directivity of the antenna. Simply 4 pi divided by half power beam width in both the plane. Just you make a product. Just to make a product. Then there is another way also you can write, because here this formula is in radian mode, because you know once this is in radian mode, numerator is 4 pi, and very clearly once the numerator is radian, then denominator also you have to put it in radian. Please be sure that whenever you are writing like this, half power beam width and half power, one is pi and another one is theta half power beam width, then whether they mention or not, this has to be in radian, because numerator is radian divided by radian, then there is no unit, because directivity will not have any unit. But sometimes they may give you in degree also. So then simply you convert this 4 pi from radian to degree. Okay, you know how to convert radian to degree, then you may get approximately like this. Okay, then 41253 and theta. Again, now here the numerator is in degree, then denominator also you have to put it in degree, theta degree and pi degree. Okay, pi degree. Okay, so how to remember this formula? Please remember this formula, then you can modify to this formula. Okay, this is one way to calculate the directivity of the antenna. Okay, so next one is parabolic reflector. Next one is parabolic. Intuitively, this is okay, because you know your isotropic radiator radiates uniformly in all directions, say like a sphere, because this is isotropic radiator. Then your practical radiator is going to radiate only in a particular direction. Say for example, 3D direction I'm telling, this is simply radiating in this direction, but not with another direction. Now antenna is here. Okay, so it is simply radiating in only one direction. Then definitely if you measure the solid angle of this practical antenna, that will be less than the isotropic antenna. So then you will get the directivity. So lesser the solid angle, more the directivity. So again, if I reduce the solid angle, then I'll get the more directivity like this. Okay, so intuitively this is okay. So solid angle of isotropic radiator divided by solid angle of the practical radiator. Okay, simply you can remember like that. Directivity is equal to, you can remember like that. Okay, solid angle of iso, solid angle of iso, solid angle of practical antenna. Okay, solid angle of practical antenna.